So, hello everyone. Welcome to the session 4 of our MERN series. Today, we are going to kickstart a journey with Node.js, Express.js, and MongoDB, three core technologies that power modern backend development. By the end of the session, you'll have a solid understanding on what is a server, how to build and connect your server with a database, an essential part of the MERN stack. So, moving on. Before we dive into the tech stuff, let me quickly introduce ourselves. I'm Ayush. I enjoy building web apps and playing around with JavaScript frameworks. You can find some of my work on GitHub and my co-partner.
Hello guys, I am P. Amrita. I'm a Monstack developer. Feel free to check out my projects on my GitHub ID.
So here is a quick look on what we'll cover today. We'll start with the basics of Node.js and understand what a server really is. Then we'll dive into Express.js and see how it helps us build faster. Next, we'll explore MongoDB, including how to structure and relate data. We'll also have a touch on Express Router to organize routes better. After that, there's a quick task for you. And finally, we'll wrap things up. Moving on. What is Cozy Reads? Cozy Reads is a digital bookshelf management server application, a part of which we are building together today. Imagine an online space where you can track your books, organize them by genre, and manage your readings. Today, I'll guide you through the basic backend development of Cozy Reads. The rest of the features will be your tasks for you to complete on your own. If you finish and send it over, you will have a chance for a interview for a special spot on a core team. So this is a great opportunity to learn and maybe even join us. So starting on, what is Node.js? Node.js is basically a way to run JavaScript code outside of a browser on the server. Traditionally, JavaScript would only run on the browser. With introduction of Node.js, it was made possible. It is built on Chrome's powerful V8 engine, which makes it fast and efficient. The coolest part, it lets you use JavaScript for the both front end as well as the back end. So you can build an entire app with just one language. Make sure you've downloaded Node.js on your system before proceeding. Now, moving on. What is NPM? NPM stands for Node Package Manager. It is a default tool that comes with Node.js. Think of it like an app store for JavaScript code. It helps you find, install, and manage packages, which are bundles of usable code that makes your life easier by solving common problems. So let's create your first Node.js script. This is an index.js file that I've created. Just console.log. Now, and just run it. One thing, after you've installed Node.js, just type this command. If you're able to see this version, like here I am able to see, it means that Node.js is successfully installed on your system. If you run directly node index.js, it might happen that it might show error because Node.js might not have been properly installed. So make sure that Node.js has been installed. So you can see that after running node index.js, I can see what I've logged it here. Now just let's try a file operation. This is just plain simple JavaScript with the power of Node.js. Here, what am I doing is I'm creating a book.txt file, and inside it, I'm writing hello world. Now, after if it has successfully built book.txt, it would say me that book.txt is created. Now, I'll again run the same script. Now, see, I have here an response book.txt has been created. Let's check out book.txt and it contains the hello world. So basically, you have created your first Node.js script. Moving on. Huh. Here comes the interesting part: Common JS versus ES modules. Node.js originally used something called CommonJS for managing modules. You've probably seen require and module.exports before. But now the newer and cleaner way is ES modules, which use import and export. They work both in browser and Node.js, making your code easier to read and more compatible. For this session, we'll be using ES modules. And later on, I'll show you how to configure Node.js to recognize your project as an ES module setup. Now, here comes another interesting thing. Package.json versus package.lock.json. Whenever you install any dependency, such as you write npm i express, it installs express, but installing express also creates two another files, two files. Basically package.json and package.log.json. Think of package.json as your app's shopping list. It lists the packages you want and some basic info about your project. Its main purpose is to tell Node.js which dependency your project needs to run. And package.log.json is like the receipt. It records the exact versions of every package that got installed. Its purpose is to lock down these versions so that everyone working on the project has the same exact setup, avoiding unexpected bugs. It might happen that in the future, such as Express, example that I took, Express got an update and its previous functions got deprecated and they are not supported anymore. So if package log.json is not present, the newer version would be installed and the code would not run. So moving on, what is a server? This is an interesting part. So everything that you use a modern app on your phone basically requires one is the front end, another is the back end. The system that runs the backend is called a server. Listen to this. A server is basically a computer or a program that waits and listens for requests, then sends back responses. In web development, think of it like this. When you open a website, your browser sends a request to the server asking for the web page. The server then processes the request, grabs the right data or files, and sends them back to your browser so that you can see the site. Server handle all these kinds of requests, not just loading pages, but also things like submitting forms, fetching data, or even handling login information. They are a backbone of the internet, making sure communication happens smoothly between your device and the data you want. Now, what is an API? API stands for Application Programming Interface. Think of it as a messenger or a bridge that lets two different software systems talk to each other. Uses, for example, when you use an app on your phone to check the weather. That app uses an API to request weather data from a remote server. The server then sends the data back through the API so the app can display it to you. The API is the defined clear rule for how requests and responses should happen. Basically, it is a set of rules, making it easier for different programs to work with each other, even if they are built with different technologies. In web development, APIs are what allow front-end and back-end to exchange data between each other seamlessly. Moving on, server versus API. So, a basic difference between server versus API is server is a physical computer and API is the code running inside. Basic is this. And to understand it more, let's take an example of a restaurant. Think of a server like a helpful person to put things together. Imagine you are at a restaurant. The kitchen is the server. That's where all the work happens. The menu is the API. It shows you options and how to request them. The waiter takes your order from the menu and brings back your food. MERN stack that we are building today is a basic example of REST APIs. Now, what are REST APIs? In web development, Uh, there are many kinds of API types. So let's start with the most common one. REST API stands for Representational State Transfer. It is built on standard HTTP methods like get, post, put, delete, and etc. And typically uses JSON to send data and receive data. REST APIs are simple, flexible, and widely used. You'll find them powering services like Twitter and GitHub. There are more other types too, like SOAP, GraphQL, WebSockets, and gRPC. But today, we'll mainly focus on REST APIs. So, what is a request and a response? Request is what the client sends to the server. It includes things like URL, any parameters, headers, and any data that the client wants to send. Response is what the server sends back to the client. It includes any data requested, status code to show if everything went well, and if not, the error messages what went wrong. This is what is a basic request and response. Now, REST APIs use different ways to send and receive data between client and server. First, there are query parameters. The these are a question mark in the URL to filter or paginate data. For example, slash users question mark role is equals to admin and page equals to 2. Let's you get admin users on page 2. Path parameters, these are dynamic path inside URL that identify specific resources, such as slash users slash ID slash profile. That ID might be any random string, but that random string represents a particular user in a particular database. So when I hit this route, I'll get the result of what are the details of the user. Moving on to request body. This is where you send complex data in post or put request, usually formatted in JSON. Moving on, HTTP methods. REST API use different HTTP methods to perform actions on resources. Uh, Get retrieves data without changing anything. Post creates a new entry in the database or creates a new entry on your data store. Put updates or replaces an entire resource or can create if it does not exist. And patch applies partial modifications to resource and delete obviously deletes the resource. Moving on. What is a port? A port is like a door on your computer that lets data come in and go out. When you run a server, it listens for requests on a particular port, kind of like waiting at a particular door for visitors. Ports help organize multiple services on the same machine, so each one has its own role to handle communication. Moving on. So let's create a basic HTTP server. Now, previously I told you what is EJS and CommonJS. Now we'll use EJS. It initializes a node project. If I type this line of code makes Node.js understand that it is following the EJS module. By default, it follows the CommonJS module that you have seen here, uh, the required statement above. Let's start creating a basic HTTP server. Now, what is this 200? 200 represents status week. There are when you go deep into Backend development, you will know more about these numbers. For example, there are numbers such as 200, which represents everything is okay. There are numbers such as 500 that represent that the server has gone some internal crashing. There are 404 for resource not found. There is 302 for handling reval. Now, Remember, I told you something about code. So, or if you guys are familiar with React, it uses the port 3000. So I'll run my server of the port 3000. Everything was the function log. So before running it, I'll explain what the script is. Basically, it defines how our program should run. There are many scripts, such as if you want to check test basically before pushing your code to production, you could write a test script and it would run any other package manage any other package that would test your code, compile your code, and finally build your code. For now, we'll be using start. Basically, what would it do? It would start our server. Instead of writing node index.js in the terminal, I'll just write npm run start. It would start a server. So you can see that our server is running on port 3000. See, it gives us at the root directory gives us hello world. And if I write anything else, it results in page one. So just now you created your basic HTTP server. Moving on. Now, Express framework. Express is a lightweight and fast framework built on top of Node.js. It gives you essential tools to create web servers without extra complexity. One of the biggest strengths is how easy it handles routing, letting you define routes for different HTTP methods and URL in a simple way. Express is also scalable and flexible, so you can build things from small apps to large complex APIs. Moving on. Now let's create an Express application. So we'll just remove this and stop the server and write npm install Express. Now remember, Express is the dependency which we use npm and install in our server basically. So start code Express. Express. Again, we need to define code number. Code number is let's say 1000 and declare a variable of app. It is that Express app.get. Now, here is the interesting part. This app.get. Get defines the get method, which I explained you earlier. There are different kinds of methods, huh? Get, push, put. So this is stack bit. When you hit a get request to this endpoint, I'll show what might get resulted. But again have two objects. Two objects are always two. One is request and one is response. It is basically how the client side and backend side communicate with each other. Just return. Now let's start a server. App.js. Okay. Similarly, a callback function that will tell us that the server is running or not. Let's again this npm run start. Now you can see that our app is now running on Express. You can already see the complexity in the code is reduced drastically. Okay. Now hit this again, hit this, and you see the different thing. The route is not defined as is saying that cannot get. At the root route, you can see that the message is okay, message is running, etc. is okay, which indicates that the server is running fine. So you just created an Express server. Now, moving on, there are some important rules that you would require while developing a Node.js backend, whether you are using a punch tag or merge tag. Uh, these vary, but these tools remain constant. One is Node1. Node1 is like a chill coding body that keeps an eye on your files. Basically, whether I'll show you something. That server is running on port 3000. I just changed it. Server is running. So whenever I reload it, it is just saying that server running on port 3000. If I'll stop it and then again start it, then I can see the change. So Node 1 prevents us this manual work. It just automates whenever you save a file, it automatically restarts a server without asking, without prompting you to do so. So it helps us that I'll just show you how Node 1 is installed and how does it work. Moving on. .env. So .env is a small but powerful tool that helps you manage environment variables like database connection string, API keys, or secret tokens. You store these sensitive details in a .env file, which you make sure not to push to GitHub, so your secrets stay safe and private. Think of .env like a diary that holds all your secrets. Just don't forget to add it to .getting. Whether the purpose of .env would just perish. Moving on. Postman. Postman is your API best friend. Lets you call APIs without building a front end first. You can send, get, post, put, delete requests, and add custom headers, audit data, check if your backend is working as expected or not. It also lets you save requests and collections, use environment variables, and automate tests. Basically, it is like a browser, but for APIs. That said, we are using Hopscotch. What is Hopscotch? It is an open source alternative to Postman that offers some great features and similar user interface as of Postman. So you will get all the power without any cost. Make sure to download these before uh, making a backend. Okay. Now let's set up node.mon.in. Start the server. Install .in. Here I'll write a dev script. Now you guys would be familiar with this if you ever work with Next.js. Basically, dev means development mode, and start means basically start works in production mode. Whenever you push your code is final, just run npm run start, and that starts and that runs forever. But npm run dev makes it for development purposes. Uh, Example, how Node1 works. And just show. I've just written Node1 index.js. Let's run npm run dev. See what happens. Now see, uh, the interface is not the same when I did just npm run start. Another thing I like to show. When I hit save, the server automatically restarting due to changes starting from index.js. Basically, what it does, it watches index.js. Now, any file that is imported in index.js watches that also by default. To prevent that, there is another file called nodemon.json where you tell nodemon to run on only these files. So not getting on to that complexities. Now let's use .env. First, I'll create a .env file. time here port equals to 5,000. Node.js port. Okay. Now, instead of this, I write process dot process dot dot port. Now, have a look at this program. This line code checks for a variable name port inside env file. Okay. If it is available, then it runs on the that specified port. Port is equals to 5,000, or else it fall back to 3,000. One thing is to mention that you should always have a fallback port. Here, for an example, I just showed you 3,000, but it should be always the port that you would be running. So if I show you what would happen if there was no. Uh, Also, Node.1 does not watch env files, so you have to this manually restart the server. Now, see one thing. It is not able to find that port defined, so it is falling back to 3,000. So, for simplicity, I just defined a port here. Yeah. Now we can see the port is run contact. So basically, you know what is ENB, what is its use, and also you know how to use Node.1. One thing, before pushing anything to GitHub, I'll push this to GitHub so that you guys can later take on a reference. First thing that you'll have is .env. Second thing that you'll have is your volumes. You don't want your GitHub uh, this GitHub repo to have cluttered with chunks of data that are not necessary. So, yeah, just push it GitHub. Uh, any questions that you guys have? Feel free. You can raise your hand if you want. Okay, I think nobody is asking questions, so everybody is fine. You can tell me the code thing why like 3,000 or not something. It can be any number, but it should be a four-digit number. Remember that. Of course, you can always write 5 5 5 5 5 four times or 4 5 times. Any number. First, the consideration is basically a port is a door. Your system has very different services running on different ports. In web development, I'll explain it to you. Your database run on one port. Your web server runs on another port. It might be possible that in the same system there are multiple servers running. When you'll build a monster application, you'll understand it better. Why? Because you'll print front end will always be built on port 3000. Basically, the React apps I'm saying that. And for Git, you see that 5173. But if you try to run the front end at 3000 and also the server at 3000, there is a clash. And either that side or this side will say you, either the front end side or the back end side. Either you start later, uh, they will say you that, no, this is not allowed. Uh, I can't help you with this. You should need to change your port number. It is a basically gateway. Uh, is your doubt clarified now, Arjun? Okay, anybody else? Questions? Moving on now. Uh, Now Amrita will take on with the MongoDB thing.
Okay, let me share my screen. Is my screen visible?
Yeah, yeah.
Okay, so now that we are done with the Node and Express part, let us start with the M in MERN, that is MongoDB. Now, what exactly is MongoDB? It's a database, right? So let us start off with very basics. What is a database? Right. A database is an organized collection of data, right? It's a super organized collection of data. Now, does it just do the job of storing data? No, it is much more than that. It helps us access data, store data, manage data, and manipulate data. Right. What exactly is manipulation? It's updating and deleting the data. Now, types of databases, there are basically two types, relational and non-relational, right? So, what is the basic difference in relational and non-relational is that in relational, there is a fixed rigid schema, but in non-relational, there is flexibility. Now, from the diagram in the right side, we can see that in both cases there are databases. In RDBMS, in a database, there are multiple tables, right? Understanding this with the help of an example, let us take the example of NITR, right? There's a NITR database. Now, inside NITR database, there are going to be multiple tables. One table for professors, one for students, one for officials, right? Let us take professor table. There are going to be multiple rows inside that table. Each professor, a single row. Now, in each row, there are going to be multiple columns, right? For a professor, we want to store the name of the professor, the date of joining, which department he or she is in, their qualifications, etc. Now, this is really great for consistency, right? This rigid schema thing, but problem arises when we want to add something. For example, for the student table, we want to add, let's say for some reason we want to add their threads profile, right? Not many people use threads, so only 5% of the students are going to fill in that column, but the rest of the 95% are going to leave that blank, right? So that column in each row is going to take up some space. 95% of those columns are going to be left blank, so this is a wastage of space, right? So in case of this, right, RDBMS, if we want to take up some new fields, new data, we have to alter the entire table. We have to add that column to the entire table. We cannot just do key, okay, for student 1, 5, and 9, we are going to take the threads profile. Rest of them, it's just like empty. There's no column for threads profile. That is where NoSQL comes in. It gives us that flexibility, right? So as you can see from the left side, there is schema, fixed, flexible, relationships. Okay, yes, in the relationships wala part, this join and usually references wala part, we will discuss that later on when we code. Use case, structure, data, acid properties is basically atomicity, consistency, isolation, and like reliability. As concerned for now, we are only focusing on NoSQL. NoSQL gives us the flexibility. Now, in case of
Amrita,
MongoDB, it stores.
Amrita,
Huh?
थोड़ा
Hello.
पीछे वाली स्लाइड चली जाओ, तेरा आवाज कट गया था. हाँ.
Okay. हाँ, कहाँ से कटा था?
Types of database.
Hello.
हाँ हाँ हाँ.
Am I audible?
हाँ
अभी
हाँ
आ रही
हाँ
है ना
थोड़ा.
आवाज?
हाँ फ्लक्चुएट हो रहा है थोड़ा सा, बस उसका देख रही.
अच्छा. Like पूरा starting types of database से कटा हुआ था.
बीच टाइप्स ऑफ database के कोई से.
Uh, okay. So types of database was basically about relational databases and non-relational database. So I gave an example of NIT Arcade database. There, like taking the example of RDBMS, where there are multiple tables, and in each table there are rows, particular columns. If we want to add some new feature, we have to alter the entire table, right? And there is no guarantee that all of them are going to be filled, like all the rows in that column are going to be filled. So that might lead to wastage of space, right? For example, I gave an example of threads profile in case of students. Now only 5% are going to fill it, rest of the 95% won't. So that will lead to a wastage of space. I'm still audible, right? Hello?
Yes, yes, you are audible.
Okay. Yes, so that will lead to wastage of space. So here comes NoSQL that gives us that flexibility. Ki there is no rigid schema. We are free to add features as we want in each of the document. The structure of a NoSQL database is kind of like this. Like tables are equivalent to documents, documents they are going to be fields. Right now, coming to MongoDB. MongoDB is basically a NoSQL database, which is document based, right? Document based means this one only, right? Collections, documents, and fields. Now it stores data in JSON like documents, which is in brackets you can see bson. Right now we have heard of JSON. What is bson? Bson is basically binary JSON. Now why binary JSON? This on the right side that you can see, it looks like JSON part, right? But under the hood MongoDB uses this bson format, binary JSON format. Why? Because it's easier for parsing and also indexing, right? It's more efficient that way. Then comes highly flexible schema. Each document can have different fields that we discussed in the NoSQL part. Same for MongoDB. Ideal for projects with evolving data structures, right? So if a project is there, there are different. It is changing. Like for now, you need certain fields. For later on, you will end up like, okay, we need these fields as well. So instead of using like changing the entire table, we can opt for NoSQL, where we just add, like we have that flexibility, so we can add those fields in a particular document. Now in the right side, you can see that MongoDB normally stores it, like as we can see on the, like overall we can see that it looks like JSON, but as we discussed, under the hood it is stored in bson. Next, moving on. Now that we know about MongoDB, next part is Atlas and Compass, right? Atlas versus Compass. These are basically two tools. Now, as you can see, MongoDB Atlas is cloud-based, and MongoDB Compass is local GUI. So what it does is MongoDB Atlas is basically used for creating clusters. Like before even connecting the MongoDB database to the backend server that we have created, we need MongoDB Atlas to give us a very important string that is known as connection string, right? It helps us connect the database to the backend server. Later on, when we are doing the connection part in the coding, we will see that. Next, MongoDB Compass. Now that we have connected the database to the backend server, we need to see, right? And we have added some, like with API endpoints, we have added some data. We want to see how the data is changing, how the data is there in the MongoDB database. That for that we can use the MongoDB Compass. It gives us that UI. It's easier because you do not have to use the terminal. You can directly go to that. You can directly install the MongoDB Compass, use that connection string there to connect to that particular database cluster of yours, and you can see how the data is interacting there. So usage is used to generate connection string for backend, used to explore data, run queries, debugs. Right now, when to use? Yes, before connecting MongoDB to your server, and Compass is for after storing, fetching data to inspect virtually. Now, yes, MongoDB Atlas is totally web based. You do not have to install anything, but for MongoDB Compass, you need to install it on your local computer. Next. Yes. Now here there is the coding part, right? Connecting MongoDB with Mongoose. What is Mongoose? Now Mongoose is an object data modeling library, ODM library for Mongoose and Node. Now, what exactly does this do? See, MongoDB itself does not have any schema, right? It's no SQL. There is no rigidity. There is no rigid rules that this schema has to be followed. But when we are working for some application, right? For some application, we are creating a database. We need some basic structure, right? For like in this session, we are creating cozy reads. So we are basically going to have two data models. One is for books, one is for authors. Now we cannot give like total freedom. It's okay, you can add a book, but it's okay if you're not adding the name. No, you need to add the name, right? So we have to specify that somewhere. So that is done with the help of Mongoose. It gives us that power to add a schema for different models, right? Some rules, right? You have to add a name that is required. You have to add an author that is required. So these things are done with the help of Mongoose, right? Yes, it helps define schemas and models. It adds structures and validation to otherwise schema-less MongoDB. Okay, so now we will do the coding part. Uh, yes, my screen is still visible, right? Hello.
Yeah, it is visible.
Okay. So later here, as you can see, right, this part. This is the function that we have to do, that we have to write to create the database to the backend server. Right. So in this, like before coding, let us understand what this is doing exactly. Uh, yes, there are two variables here, but we will be using one variable. Actually, let's directly code it. We will create a file named db.config. Okay. Now, it's okay if you're naming it in some other way, but this is like a common convention. And also, right, this connection wala code, you can also, connection wala function, you can also write it in index.js, but the thing is, it ends up cluttering the index file. So that is not recommended normally. Now, starting with, we will, okay, let me check the JSON actually. Okay, so we will be installing Mongoose first, and we will also install MongoDB as well. Right, so as it is being installed, let us wait. Okay, it has been installed. Let us install MongoDB as well now. So we will start off with importing Mongoose from Mongoose, uh, right? Next we have to import .env, uh, .env from .env. This is for using the system environment variables. Next, to use the environment variables, there is .env.config. Right. Okay. For now, we haven't we haven't made the written the environment variables yet. We'll come to that later on. Right. So basically, there is a function const connect db connect database. It is going to be an async function. Now, why is it going to be an async function? Is key connecting to the database is going to take some time, right? Connecting to the database is going to take some time, but we cannot wait that much. We cannot hold off the other process for that much time, so we use a async function, right? Now it is always good practice to use a try catch block so that if any error is there, it helps us catch that, right? uh, okay, now for await mongoose dot connect. Now inside this is going to be uh, the connection string, which we will later on see. Next, once it get connected, we have to console log a success message that yes, your database has been connected. So MongoDB connection is connected successfully. That is right. Right. Then, if there is an error, let us write. log MongoDB connection failed, and we can write the error as well. The error was this. Right. Now coming to the that part, and yes, let's export it as well. Port default connect db. Right. First, let's create a env file. .env. Okay. Now for the connection string part, we need to open MongoDB at last. You can just search up MongoDB at last. Then if you have an account, well and good. If you do not have, just it's quite intuitive. You can create an account there. Now after doing all of that, you can see clusters, right? Now in the clusters part, uh, see there is a cluster 0. First it will prompt you, like if you haven't used MongoDB at last before totally, then it will tell you to name this as well. The default name is normally cluster 0. So yes, this is, you can click connect here and see this part is done, right? The setup, if you go back, see this add a connection IP address, create a database user. This I have already done because I've used MongoDB. If you're starting, like if this is your first time, you will be prompted to do this as well. Now this part, uh, just a minute, this connection IP address is basically like this part, right? Network access, this IP address is what, this you can access the database from these listed IP address only, right? This 0.0.0/0 means that you can access your database from any IP address. This is not recommended if you're working professionally, because normally if you're working on a database, you add your backend, like you have deployed your backend somewhere, you add that link here, right? You add that IP address here, not just any, like you do not allow the access from any IP address. So this is done. Now going back to cluster wala part, how do we connect? Now you go to connect, choose a connection method. As we discussed, right? There is atlas and there is compass. If you want to use your compass as well, you can access the Mongo, like your database, through this. This is the string you will be using. Now going back, because we are working on VS Code, we will be using this, right? Drivers wala part. Now, yes, it tells us to install MongoDB. We have done that. Now, this is the connection string, right? MongoDB, this is your username, right? This is the password, and this is the cluster. Now, this here you see there is a slash and a question mark. Here, between this slash and question mark, you will have to add the database name, right? Which database you are using. Now, what do I mean by database? Here, if you go to the cluster and then collections, see here you can see multiple databases, right? There is cozy reads, there is MERN library 21, there was some default sample mflix, right? So between that slash and question mark, you will have to add this particular name. You can add any name basically. Now let us connect it. So we will do Mongo URI, right? In Mongo URI, we will be connecting it. Now I have already like written the URL here. This is basically my username and the password that was there. And here see between the slash and question mark, I've added the MERN library 21. Now, why I'm using MERN library 21? Before I added some, like populated the different collections, like in authors we have added a few, so that it will be easy when we're showing the different endpoints, like get endpoint and all that. It will be easy to show the already added data, right? So we'll be using this one. Otherwise, if you want to know the like creation process, you can just create a database and it will be the process is quite intuitive. Okay, so let us use this one, right? Uh, okay, now we can directly use that. Yes, so there's process.env. Now this is a process to use any env variables, and you can just add the name, this one, right? Now in the index.js, you have to import this connect process, right? connect DB, import connect DB from slash db.config.js. Okay. Now after config, we can call this connect DB part as well. Now let us run it. And if okay, so here you can see the thing, see the message MongoDB connected successfully. Apparently, I did a typo here. I did the spelling wrong. Well, that doesn't really matter, right? Okay, so MongoDB connection is done successfully. And yes, if you're working from hostels like I am currently at college, MongoDB doesn't work. So use your own net, right? At college Wi-Fi, it doesn't really work. Next is okay. Now going back to the PPT. Now that we're done with the connection part, let's move on to data modeling. Now, what exactly is data modeling? Planning how your data will be structured and related. Now, any database you are planning, there are going to be certain models, right? There will be, as for the example of Cozy Reads, there are the book model, there is the author model. If it would have been more complex, there would have been the users, right? There would have been publishers. Now we are keeping it simple, so there's just books and authors. So basically, we are planning, right? In books, what all fields are going to be there. In authors, what all fields are going to be there. So that is what modeling basically is. Now, why we do that? It prevents messy schemas, clarifies relationships, saves time during actual development. Yes, it prevents messy schemas because okay, if you're working, if I'm creating a model of books, I need to take the name and I have to make it required. We will be mentioning that in a data model. Later on, I'll show how a data model looks like. Next, clarifies relationships. Yes, for example, we will be clarifying in a data model that a single book can be written by a single author. We are considering that a book is not being co-authored by more than one authors, right? Only one author is there to a single book, right? Now this is what clarifying relationship is, whether it is one to many to many, or many to one. Saves time during actual development. Yes, if you have the model, you can directly see that, refer to that, and write the model. We will be doing that later on. Now, what are the tools to do this data modeling? There is Moon Modeler, that is paid, that is used by professionals. But since it's paid, we college students basically use Eraser.io. If you know anything else, you can use that. You're free to use that. Now, I personally use Eraser.io, the data model that I'll be later showing you, that is made with the help of Eraser.io, right? So, yes, designing data model. Yes, the diagram that you're seeing on the right side is made with the help of Eraser.io, right? In Cozy Reads, we'll be working with two main models, as I said, author and book, and relationship. Again, here you can see, right? In author, it is written one. In book, there is a star mark. So that is one to many. That means that for a particular book, there is only single author, but an author can write many books, right? So that is the relationship wala part. Next, moving on, yes, model relationships. Now, before moving to model relationships, let's actually code the models, right? So we will be creating a file, a new folder, actually, that is the models folder, right? And in the models folder, there are going to be two models, right? One is book.model.js. Another one is going to be author.model.js. Now, .model.js is still a JavaScript file if you're wondering. This is just a naming convention, right? Now, again, we have to import mongoose from mongoose, and then we will be creating a schema, right? This is author, so this is going to be author schema. Author schema, right? Now, when we are creating a schema, this is going to be with the help of mongoose, new mongoose dot schema. And yes, inside this, there are going to be two parameters. Here you see the first one is for defining schema. The second one is for timestamps, right? Why timestamps? S, because it gives you two things. One, created at, second one is updated at, right? This is given by mongoose. So timestamps will make it as true. Then the next one is, yes, Now we'll be defining the different models. So again, let us see. In author, this ID part is generated automatically. We won't be defining it in the model. We need name and we need bio. The types are string, right? This is the type part, the string. Okay, so we need name and the next one is bio, right? Now we will be defining this. Name, uh, the type of name is string, right? Next, do we absolutely need a name for author? Yes, we need that. So we have to make it required, right? So required, we will set it to as true. Okay. Now for bio, again the type is going to be string. But for now, it is okay if the author doesn't really add a bio, but let us make it true because we're only taking two parameters. Let us make the required part true as well. Required is true. Now, once we are done with the schema part, we have to export it, right? So, how do we connect it to the model? How do we connect it to the MongoDB? This is for Mongoose, right? This is done with the help of Mongoose. Now, our MongoDB needs, our database needs something so that it will know, okay, Mongoose has set up this schema for me. So, for that, we will create something called author. Uh, author that is equals to, okay, Mongoose dot model, and it takes up two things. One is author, the name of the model. Another one is the which schema it is based on. It is based on this author schema, right? Now normally the this name that we are writing here, author, this actually is converted into like this small, like it is converted to all small cases, lower cases, and an s is added. S is added at the s. This is done by MongoDB itself. We don't need to do this by ourselves, and it is good practice if you're naming these two as same, because there might be a chance that you're naming it different, and while you're exporting some mishap happens. We'll discuss that later when we are referencing, right? Okay, so now that we have to do export default author, we have to add another thing here that was not there in the data model actually. uh, that is books, right? Now we will come back to this later on once we have decided like written the code for books wala part. Now for books also the same pattern, import mongoose for mongoose. Now here the schema is going to be that of book, right? New mongoose schema, all same. Yes, this is going to be different. So here we will need title, genre, pages, published here. Okay, so let us write. We will need one title, another is going to be genre. The next one I guess was pages published here. Okay, pages published here. And next I think was okay, next is author. Okay, so here in these cases it is quite simple, like we just be writing the type. In most of the cases is going to be string, and is the title necessary? Yes, it is required, so this is going to be true. Right, so we can just copy paste this. Genre we will make it required. Pages, it's okay if it's not mentioned, so this is number and we won't set the required parameter. Published here is again going to be number, and it's okay if it is not mentioned, right? So we won't set the required parameter. There are many more parameters, like there is lowercase parameter and all that. There is enum as well. Right. So in all these cases, you can just refer to MongoDB docs. There are multiple parameters, right? Covering all of that in this is not really possible. So yeah, just for now, we are sticking to types and required. Okay, so the author part is going to be a bit tricky, right? In author, it is not exactly a type, right? You're referring to a particular model. You have to connect it. Now, you must be remembering that I mentioned in this case, in the case of RDBMS, that there is join thing, right? To refer to author with the help, like from the book table, if you're referring to author, you have to join the two tables, right? But in case of MongoDB, it can be easily done with the help of referencing. Now, what do I mean by referencing? Here, what you will write, the type is, you will write mongoose dot schemas dot schema dot types dot object ID. Now, next you are going to give a reference. Now, this reference is going to be same as this name, right? It is okay if these and these are different. That is why I said ki it is better if you're naming these two as same. It just like avoid easier to avoid confusion that way. So this name is what you have to use in the case of in this case while you're referring, while you're giving reference, right? So author type is, this is author required, yes it is required, so we will set required as true, right? Okay, I forgot a comma there. Okay, so similarly, in case of uh, right, this is book schema. Here also we have to change. This is going to be book. This will be book as well. Then we will export default book, right? And yes, the schema has to change to book. Okay, so we are done with the book model. Next, coming back to the author model, right? This books wala part, the author can write many books, right? So is book going to be a single value? No, it is going to be multiple books, right? So it is going to be an array of books. So this we denote with the help of a square bracket. Now each array is going to contain a book. Now that book is will be a reference to this book model, right? So it is going to be again similarly. We will write a type, then we will do mongoose dot schema dot types dot object id, right? And then there will be reference to what? Reference to this book. Again, this name has to be same with this reference wala name, and yeah, it will be within inverted commas. Okay, now it is okay if author hasn't we are not writing the required thing here. Yes, the rest of the rest of the thing is done. So we are done with the author model as well. Now we have exported it. So later on, while we are writing the endpoints, these are going to be imported and used there. Next, moving on, model relationships. Okay, one to one to many to many. This is quite like you can understand from the headings only. One to one is what? For example, a student. A student has one ID card. A ID card can refer to only one particular student, right? A one ID card cannot belong to multiple students, right? One ID card to one student to one ID card. That is one to one relationship. One to many is again like a single student can belong to only one branch, but many students can belong to a single branch, right? So that is one to many. Many to many is take the example of clubs. A single student can belong to multiple clubs. A single club can have multiple students in as a member of it, right? So this is model relationships. Now, okay. So the question is, if anyone must have thought of this, if MongoDB is called schemaless and flexible, then why do we still define fields and structure using Mongo's model in our code? Where is the flexibility really, right? For example, while we are defining the model, we said ki required is true, right? So that means that in that model, we have to, like for that collection, we have to, sorry, for that particular document, you have to enter that particular field, right? For books, you have to enter the name of that book. So that is some kind of rigidity, right? But we just discussed ki MongoDB is flexible. So now, is it really flexible? That brings us to MongoDB does not force structure. We chose to add it, right? The point of adding Mongoose was that only. Ki MongoDB doesn't have a schema. It isn't enforcing any schema on you. It isn't telling you ki just you have to follow this particular structure. It is okay if you're not following it. MongoDB is chill with it, but we are not chill with it, right? We need a title for a particular book. It like you cannot go to a library and say, okay, this book doesn't have a title. We need it. So that is the reason why using Mongoose to let the person who is entering the data know ki okay, you have to enter the particular title of that book, right? As you can see on the right side, there are three documents belonging to the book's database, right? There are title common to each of the document, but the rest of the features are different. Rest of the fields are different. Author pages in the first one, second is published year tags, third is ebook downloads. Now these all can belong to MongoDB books collection without any error. It is not going to throw any error at you. It is totally chill with it. But if this title thing would not have been there, then we as an application, like we are handling the library, we would have faced some errors, right? That is why we are using Mongoose to make sure that this is compulsory, this is required, rest you are flexible, right? MongoDB is totally flexible. So as we have said here, ki MongoDB allows flexibility. You can insert any shape of document. Even if fields are missing, it is still with it. But our application adds structure. That is why we are using Mongoose. A very easy way to real world example we can understand this with is, for example, let us take the example of a diary, right? MongoDB, each page is like a document. Inside each page, you can write anything you want. You are free to add. But in case of let's take the example of a journal. It is also a book. You can also write anything you want in the pages of a journal, but it has some fields, like you have to enter the date of that journal, like date of the particular day in that page of a journal. You have to add the title or any heading you want, or page number, right? So these are particular fields that are predefined, that you are required to fill. So this is what basically MongoDB Mongoose is. So next, it is like building the API. From here on, Ayush is going to take over.
Just push everything.
Okay.
Uh, guys have any questions? Anyone? Prithvi, Ronak, Anupam?
Okay, no questions.
So starting. So one thing, I would be making directories for two basically for two simplify things. One is routes and one is controllers. Think of now what are controllers and what are routes? Routes are basically endpoints which you would hit to get data, and the brain that calculates within the database, which handles all the database operations, chooses to do things for you so that you get what you want, is called a controller. Starting off with a controller, and just like due to time constraints, I will just write one controller and just copy paste from my previous iterations. and just write a function to get all authors. Get all authors. Also, as Amrita said, it is a nice way to always handle errors gracefully, or else your app will crash. We'll use try-catch. Now, the authors will always get two things. One is request and one is response. Right in here, request and response. Response authors equals to await for the database operation to complete. That dot find just a second. This just dot response. As said, status represents a particular code that the operation has happened successfully or any error has occurred. So, if in case error has occurred, then where it has 500, generally 500 represents internal server error that something bad has happened with the server. Now, let's see the particular rough for author. Express provides us the package itself, uh, route data package. We want when a user visits localhost 5000 slash API slash authors, then we show every author that we have in our database. So that dot get slash the get authors function. Now how do we use it? Going back to index.js, just import it, author routes, routes, slash author output.js, this and purpose. Another interesting feature of Express.js, what is use app.use? Basically, it is a middleware function. What is a middleware now? You might ask. Before completing a request, uh, where if a particular snippet of code intercepts it and makes the uh, server understand, कि, chalo, this part of the code is coming. I need to do this. Then the role of middleware comes here. So when we hit a route slash API slash authors, I want to list every route that is inside author controller, author route basically. So I'll write author routes. We just check the concept once again. That's okay. I want to check. You can see the database is connected successfully and the server is now running on both 5,000. Now, uh, when I hit this route slash API slash authors, if everything goes well, I should see all the authors that I have in the database. I've already pushed some authors into the database so that I don't waste any time here. Once, another thing, MongoDB Compass. So as Amrita said, it is another UI tool for exploring MongoDB that is installed locally on your machine. So I'll just the URI here, just connect to the database. So basically, it was this database that I was going to connect. Here you can see that authors are already there. So when we hit the route, I should see these authors. So Hopscotch, I told you that it is a open source alternative Postman. 5,000 slash API slash authors. Let's get us in get request. You can see our server gave us back all the authors. Now, what is this author dot find function doing? See, the find function basically, if you don't give any parameters to it, would list out uh, all the documents inside a MongoDB database. If you are familiar with SQL, it is similar to select star from table. Okay. So here, if you want to get an object by ID, it is also already written for the book controller. I'll just create one. Save time. I'm just copying all these. Just explain it to me one by one. Now, see this. Here, there is a particular function find by ID which finds. See, what is a ID? ID is this that MongoDB generates automatically so that it is always unique and does not cause duplicate data entry. Okay. So if you enter this ID into uh, the request params, then you would get back this book. Basically, it means that. And one thing, populate author, as Amrita explained it to you, that author is related to books, books is related to authors. If I don't write this populate author, it would just give me back this object.id, this author ID. But due to this populate function, it actually fetches the author with this ID. Understood? I'll just write the routes for it. Again, if I hit this route, get route slash route, club, basically I'm saying this similar to author routes and this route, self book routes. I've got use. Okay, I've got use. Yeah, slash use, slash use route. One. Whenever I use slash API slash books, app.use middleware tells the Express.js that all the functions that needs to be ready are these functions, book routes basically. And book routes internally handles these controllers. So you see everything is linked. From the index.js, you go to this middleware. Middleware tells Express to call these functions when this route is hit. These functions called upon these function in turn call these functions book controller.js. It makes your code organized. As Amrita said, you could always write everything in index.js, but uh, code readability is also a big factor while developing large scale applications. So let's just test this. If it all books are working or not. Sure. Same issue. So Basically, you need to keep in mind all the import statements, app crashes, and this. Uh, you can see that I have the list of books with me that are in my database. Now, let's go on to the main part, that is the controller part. See, uh, a controller is a brain of every router. So, what Get All Books does is await in the book model, finds every uh, book and then populates its author. Now, you can see that author is an object that is coming from a whole. If I just remove this populate author, just click the request, you'll see it will just give me an author ID. So this is how relations happen in MongoDB. Now let's go for a get book by ID and just check the route once slash ID. Uh, let's just get Game of Thrones. It gives me back the Game of Thrones data. How does it work? I mean, this after you put this colon, it makes Express understand that yes, it is a query parameter. So whenever I will use ID inside this, uh, let's say this request.params.id. What is this ID? This thing after this colon. It tells Express.js that something with ID is coming in this router. For example, when I hit this request, this is what the ID represents. Okay. Yes. Now let's just create a book. I'll hit the post request. Oh, understand. Now there is another middleware that you need to use when you are dealing with JSON data. Let's have to first. It tells Express that JSON data is being in use by default. It is not enabled. This is the middleware that enables JSON data to transfer PC from uh, client to server. Okay, or else it just sees everything as a text or string. Okay, post request at create book. Okay, just have a new data here. Now where it is. Uh, for I think the data is but it's there. And you gotta return transparent or something. So now where it is. I'll just save it this one. That's the region. And now I just post request with this. Let's see what happens. This successfully created. Now let's look at what does it do? Basically, I'm sending data in request body. As you can see, what is its type? It is application.json. Application.json. I tell Express that see, I'm sending JSON format data to you. You just better pass it so that it can be used later on. So it passes it request.body takes out from it. Request.body is basically this list that I'm sending. From this, it extracts title, author, published year, genre, and pages, and then creates a new book using the dot create function and given by Mongo. One another interesting thing is to note that the status code. Whenever a new entry is done in a database, will always see 201 record created status code. Okay, and 400 represents a bad request. For example, if a malform data happens, so 400 requests was Mongo, so I'll edit it. Let's go on to Updating the its type patch. For patch to work, we need the ID. Let's change the change the pages to 500. Okay, not longer it is. Static changes the data to not longer it is and the pages to 500. Now, here is another interesting Mongoose function that I would like to present it to you. Now, what is the logic behind it? Basically, it searches for that ID inside the database. If the book presents here, if the book is present, then what does it do? See, find by ID and update. Mongoose has very friendly functions that specificate from its name itself. Find by ID and update means ID should go or update go. So, what does it take? Request.params.id. Again, this is params that I explained it to you. In the route, you can see that it is all again accepting both one and ID, which means it is accepting a param. Also, uh, uh, request or params.id. Also, it is accepting a request or body. And now, body could be anything depending upon it is validated or not. See, title, author, published, genre, pages. These all are body data that are extracted. If something is present, it would just update them, and if something is not present, it would just leave them as it is. Okay. So, what happens if I do not put this new equals new common true? New is true. See, let's see. Uh, just change just now. See this. Not longer use, not longer address. Let's change the page. Continue. See, see, the data that we receive is not the existing data. Okay. If I hit a get request to this, you will see the date changes have been made. See, not longer IDs and pages will be. But what happens is whenever you basically update a book, update a document, it does not by default return you the updated value. It returns the previous value. So for this, it is necessary for the and run validators are this are some so that you do not pollute your document. You do not put garbage data that is not necessary. Okay. Again, populate author. I explained it to you. Book is not found. Turn response to syntax is understood. And now deleting a book file by ID and delete. Says what it does. Again, if I hit a delete request, the same ID, save delete, book deleted successfully. And now if I hit the get request, I will be not able to see the book. So this was all. This was how build a basic Express server. Okay, let me just congratulations on building your first Express server. Now you can call yourselves a minor backend developer. Jokes apart, uh, we have much more exciting coming up for you. For completion of this project, see, we have only did some part of it. Most of the part is left only because we did not define user model. We did not have user routes. We did not put auth. This is what we are asking you to do. If you could see my screen, this is what we want you to do. Uh, uh, what is the challenge? Show off your dev skills by building an awesome digital bookshelf app where users can add books organized by genre, track reading progress, and create personal reading lists. This is your chance to create a full stack MERN app. What do we need? We need a RESTful API backend. You could always use our backend as a starter point. We would be happy if you implemented it. Bonus point if the UI is better, the React code is nice. Uh, This all would be given to you again. Uh, any questions uh, that you guys have? Guys, any questions? Are you stuck anywhere? I'll assume that there are no questions uh, leading forward. Thank you for our presentation. I hope you were not bored. And again, you connect with us. Uh, so, uh, slightly underrated, but what database do you all use in college then? See, there are many types of database depending on your usage. MongoDB is used when you have unrelated data. Suppose you do not want a particular schema. For example, a song. A song might contain URL to that particular song, metadata, and that metadata can be a particular format or not. See, this is not something that data is always uniform. Generally, in production and in bigger industries, we use SQL and different forms of SQL like PostgreSQL and that MySQL. There are many different forms, and when you grow big, there are many different types. You will explore vector databases that LLM models use to basically train the RAG models, etc. College, in what aspect are you asking that the MongoDB does not work in that aspect, Anupam? Eh, See, it is not necessary that MongoDB runs only with the deployed servers or MongoDB Atlas. There is also one thing called MongoDB server. Just show it to you. See what this do na just runs your MongoDB locally on your machine. You would have to go through the setup to install it. I'll just quickly show you what mine looks like. Basically, you see this localhost 27017. I just connected to it. Uh, Actually, I guess my MongoDB server is not running. So, so basically, you do the same thing but locally. Do this. So everything. You might not be able to connect to Superbase as well, if I am not right. So there are many restrictions in college. Everything has its alter. You could locally install everything, such as MongoDB. You could locally install Postgres if you want. Is your doubt clear? Proceeding further, uh, you always connect with us. Uh, if you want to join us by the traditional method, please follow this link. Thank you. That's a wrap. I hope you enjoyed our session. Yes, that's I haven't done. I did not get it. Oh, okay. No issues. Thank you. That's a wrap. Me and Amrita would like to conclude from here.
Okay. Thank you guys for joining us.
Bye bye. Just end the meet here.